The descent sequence failed, while the spacecraft was still falling through Martian air. Mission Control at ESA watched a clean telemetry stream suddenly declare something impossible. Schiaparelli's altitude line dropped below zero, even though the lander was clearly still in descent. On screen, the number did not hesitate. It crossed into underground space while nothing outside had changed. And that single reading began a chain the system never recovered from. Inside the control room, engineers saw the visual anchor appear on every display. A thin altitude curve, bright against a dark grid, sliding beneath a zero line that should never be crossed in flight. The lander was still hundreds of miles per hour above Mars, still inside atmosphere, still executing entry. But the onboard system had already declared a different reality. ESA controllers would later confirm what they saw in those seconds. One inertial measurement spike had saturated the sensor for barely a second. That was enough. The system believed it had touched ground while it was still falling. And once that belief formed, every following action was based on a planet that did not exist. The first response was automatic, not logical. Schiaparelli's landing software treated the negative altitude as confirmation of touchdown. Parachute sequencing shifted out of its planned window. Heat shield separation and descent timing moved forward, as if the surface was already beneath it. The visual anchor flickered again on mission screens. The same altitude line, now behaving like a lie that kept repeating itself. Controllers tried to reconstruct the timeline in real time, but the system inside the lander was no longer aligned with theirs. It was acting on a world where it had already arrived. But that was not the part that made the situation dangerous. The real failure was what came next. The lander's logic chain began removing steps that no longer made sense in its internal model. If it was already on the ground, then long braking burns were unnecessary. If it had landed, then descent thrust was waste. So the system shortened its own engine firing while still high above Mars. The parachute was jettisoned earlier than planned. The visual anchor returned again, sharper now, showing altitude continuing to fall while control assumptions collapsed upward. Each correction made the descent less stable, not more. The machine was not malfunctioning randomly. It was obeying a false certainty with perfect discipline. Midway through descent, the scale of the error expanded beyond a single sensor event. ESA engineers later reconstructed a full failure cascade hidden inside that 1 second of data. The inertial measurement unit had briefly saturated during rotation, producing a negative altitude spike. That spike fed directly into autonomous decision logic, and from there, every subsystem followed it as truth. Thrusters fired for too short a duration. Navigation updates reinforced the same wrong position. And descent control stopped compensating for a landing that had not happened yet. The visual anchor appeared again on replay systems in mission analysis. Now it was not just a line on a screen. It was a time-stamped moment where physics inside the machine split from physics outside it. A single second had rewritten the meaning of every following second. Then came the final phase, where recovery was no longer possible. The lander, now effectively blind to its true altitude, continued its shortened burn sequence as it plunged. It did not correct because it believed correction was already complete. Telemetry still flowed, still clean, still calm. That was what made it worse. Nothing inside the data looked panicked. Only wrong. The visual anchor reappeared one last time in mission reconstruction. The altitude curve dropping past zero again, even as engineers scrubbed through radar and tracking data, showing the vehicle still far above the surface. The contradiction became physical in consequence. Fuel burned out too early. Velocity never fully canceled, and when contact was lost, it was not a mystery of disappearance. It was a machine completing a landing that had only existed inside a single, saturated second. After impact, analysis confirmed the final truth. Schiaparelli did not fail from lack of capability. It failed from accepting a momentary measurement as absolute reality. 1 second of corrupted sensing had overwritten every safeguard built into its descent logic. The visual anchor that once showed a harmless dip below zero now represented something larger. Not a reading error, a belief error, inside a machine traveling too fast to question itself. And the landing sequence, designed to survive uncertainty, collapsed the moment uncertainty looked like certainty. ESA's conclusion was simple and unforgiving. In autonomous descent, reality is only what the sensors survive long enough to report. Everything else becomes action. The last frame in the replay shows the same altitude line. Still smooth, still confident, still below zero while falling through sky. And it was never underground at all. 1 second decided everything.